In this video, we're going to walk through the first two menu items of SQUID3 with the goal of importing, evaluating, and editing a shrimp XML file for geochronology. There are two types of projects in SQUID3, geochron versus ratio. A geochron project has all the equations needed to derive an age already built in, while a ratio project has no built-in equations. It will simply strip off background and generate the ratios that you request. You have ultimate flexibility, but ratio mode is still definitely in development. So in this video and the ones that follow, we're going to work on a geochronology project. And in this case, we're going to load a single prawn XML file. Be patient while it reads the file. If you're playing along at home, bring in any old shrimp geochron XML file you have. It's actually nice to bring in an imperfect file so you can see the power in this. We'll give this project a name. I like to use the name of the XML file. You can include the analyst's name if you like. And then generally, the first thing I do is I save the Squid project. I like to save it in the same folder as where the data resides, and it will be given a .squid file extension. With this housekeeping out of the way, you can now set some project-wide parameters. For example, whether or not you want to use SBM normalization, which index isotope you wish to use for common lead. These are both items that you're familiar with from the main panel of SQUID 2.5 data reduction. But here you can also make some selections regarding items that were contained within SQUID 2.5's preferences interface, which includes interpolation style, so we'll do a spot average, as well as the default common lead correction and default physical constants setting, and minimum thresholds for errors. Once you've got this set up the way you like, you can click on Set Default and it'll remain like that for all future projects. As a general rule when navigating SQUID3, you move through the menus from left to right and then often from top to bottom within each menu. There are hints regarding the next steps that you should take given in these blue boxes at the top. So our next step is to go to Data, Manage Sample Naming. Here we define the sample names either by setting a delimiter or the number of characters. If there were duplicates in this set of analyses, they'd be flagged here, or if I made a typo in a sample name, it might show up as a separate sample here. If I did see something off, I would make a mental note of it, because next we go to Data, Manage Spots, and Reference Materials. And it's here we can easily correct any errors in sample naming, and we do that by selecting the offending analysis, going down to the bottom, revising the name, and clicking on Save. It's also possible in this window to remove analyses. Say, for example, you realized that you had data with both 3 scans and 6 scans in a single data session. You could click on it and then right-click and remove the spot. As an aside, SQUID3 Math is not equipped to deal with data sets that contain different number of scans within a single session. It won't crash the program, there just might be some variability in the math with what you would get from SQUID 2.5. Also in this window, you will specify your reference materials by filtering them from this list and then copying them over to the upper right-hand box here. You'll also do the same for your concentration reference materials, which in this case is different, so we'll copy a different set down here. For both the reference material and the concentration reference material, you will select the model that contains the accepted values. So in this case, it's the ages are the accepted values or the accepted concentrations. There's more to say about models, but that will follow in a separate video. I will flag, however, at this stage that the uranium natural abundance ratio is included in the reference materials model. The next menu item that I'll show you is not required in order to process your data, but it's very useful. It's this Audit Raw Data menu item. Here you can see all the analyses contained in your XML file at a glance, with the different isotopic species in your run table shown from top to bottom, and each individual analysis shown left to right divided by these red lines. If I drop down this little menu here, I can change which species are shown by dragging them over from available masses into displayed masses, or back again. And I can also change the way time is displayed from normalized time, where every analysis is the same width, to hours, which allows you to see if there were any big time gaps in your session. You can also request other graphs, including your primary beam intensity or your QT1Y, QT1Z voltages, and those will be displayed towards the bottom here to help you evaluate data quality. I really like to use the primary beam graph to evaluate my data. If I had a primary beam dropout during my run, this would also lead to the SBM going to 0. SQUID3 will recognize this when you load the file and will tell you to deselect SBM normalization in the Manage Project window until you rectify this situation. But my preferred approach instead is to keep SBM normalization selected, then go into Audit Raw Data, find the offending analysis where the primary beam went to 0, and then delete it there. In this particular instance, I can see that the primary beam intensity was very stable throughout, so there's no need to make any changes there. Just like in the sample naming window, you can remove analyses from this data audit window. You do that by selecting the window and then right-clicking on it, and you can remove a selected spot. It's also possible to do a multi-select by clicking it and holding down Shift to remove data. I'm going to go back to the normalized time axis here. In this window, it's also possible to split an XML file into two parts. So again, you would find the analysis where you wanted to split it, right-click, and you can split the prawn file using the original unedited XML file, or split the prawn file using the edits that you had previously made. So if you had revised a file name or removed an analysis earlier on, those edits are preserved here. When you do this split, it makes two XML files called Part A and Part B and automatically saves them to whatever folder contains the original SQUID project. Note that unlike time window splitting in SQUID 2.5, you can split the file anywhere. It doesn't have to start or finish with a reference material analysis. The final utility in this window that I want to show you is this Displayed Mass Deltas tool. This is here to help you identify analyses where something has gone off mass. For example, periodically at the GSC, if we have a very low uranium and young sample, the auto-centering on 206 in the run table latches onto the wrong peak to something just slightly lighter than 206. You'd see this in a change in the offset between the reliably large and centered zirconium peak and the 206 peak. We can monitor these offsets using this tool. So we would do that by adding a pair where we want to subtract one from the other. So in this case, we'd want to, the mass of interest is 206 that we suspect went off mass, and the one that we're quite confident on is the zirconium peak here. So it will subtract mass B from mass A and show you the difference in a panel towards the bottom here. There's the delta mass. And here you can see in this data set there is very little difference, just a few milli-AMU throughout, so it's within the expected range of mass offsets. So, well, that's how we use this at the GSC. You might find other ways that this tool is helpful for you. I do want to point out that when you remove a selected spot from SQUID3, it doesn't delete that spot from the XML. It just excludes it from future calculations. If you wanted to create a new XML that preserves these edits, you would do that here. Save project data as prawn data file. And finally, if you had a pre-existing SQUID project that you were really happy with, the task and the settings from start to finish, you could replace the data in that SQUID project using this menu item. This is a bit of a hangover from earlier days in the development where we didn't have as much task functionality. So I don't think you'll use this, but I'll mention it just in case. At some future point in the software development, this option might be removed altogether. So now you're familiar with the basics of importing, auditing, and editing raw XML data in the SQUID3 environment. There's a lot of power in here, and it's a lot easier to accomplish these editing tasks in this environment than in earlier versions of SQUID. I encourage you to play around with it. So now, following this blue breadcrumb trail guide, in the next video, we'll move further along the menu bar to tasks.